Hi students, I will talk now about section 4.3, which is Newton's second law, which is one of the most important laws in physics. Let us now study force applied on object in different ways. First one, if we have force 10 newtons in I direction and the object initially with velocity 0 meters per second, what you expect will happen for the system? The object will gain velocity v2, which is bigger, larger than v1, which is 0 or v0. Then we have positive acceleration because v2 is larger than v0. Then change in velocity is positive over the delta t. Then we have positive acceleration. Then we have change in velocity for the object that goes under that force, applied force. And the direction of that velocity or acceleration will be in the same direction of the force. Let us now talk about another object with initial velocity not equal to 0 but equal to 2 in I direction. And the force, again, it is 10 newtons in I direction. If we have a body moving in a certain velocity and we have an applied force, we will expect that this object will increase its velocity. Then its velocity will be bigger than 2 later. Then also we have positive acceleration. And this acceleration in the direction of that force. Now, if we have a moving object in positive x direction, but the applied force, all of its component is in j direction, maybe in negative j, maybe, okay, and 0 in x component in x direction. Then this object, its motion in positive x and the force in y, then the object will change its direction. So the effect of the force will be change in the direction of the moving body. So we have change in velocity, we have change in direction. Also, if we have this object which moves in positive x direction, I hat, and we have force negative 5 I hat, which means it is in the opposite direction, then the velocity of the object will decrease. So v2 will be less than v1 or v0, and we have negative acceleration. So if we have acceleration, even it is negative or positive, or change in direction for the motion, for the moving body, then we have applied force acting on an object, and the effect of that force depends on the mass of that object and the magnitude of that applied force. Then we have positive or negative change in velocity, which is acceleration, or change in direction. Now let us see this example. Okay, don't need this, or this. If we have this mass 5 kilograms with applied force 10 kilograms in I direction, then this mass will accelerate, and we have acceleration at this amount, for example. Also, we have another mass with the same force. Then this mass, because it is 2, which is less than 5, then the acceleration for this mass will be bigger. You try to act by a force on a small body or a bigger body object, you need more force to accelerate the more mass than the smaller one. Or, in other words, if you applied the same force on two objects, one of them is heavy and the other is light, then the lighter one will accelerate more than the heavier one. Look. Also, if we have a third mass, which is 10 kilograms, and the force is 10 newtons, then we have a little acceleration because the mass is heavy with respect to the first two. So we need more force to magnify the acceleration for the object. And the small mass will have greater acceleration, as we see in the second case. Finally, the second Newton's law formula, F is equal to m multiplied by a. F is a vector, a is a vector. The direction of a vector is in the same direction like F. This is Newton's second law. So a is equal F over m, and m is equal to the magnitude of F divided over the magnitude of a. For example, here, how much the acceleration? It is F over m. The acceleration will be 10 over 10, which is 1. But in this case, the first one, the force is 10, the mass is 5. 10 divided over 5, it will be 2. So the acceleration is 2, bigger than this one. Also here, 10 over 2, it is 5. The acceleration will be 5, which is the bigger one, because the mass is the smallest one. Another example in 2 or 3 dimensions. We have the force. The force is a vector in x and y and z direction. If we divide the force over the mass, which is the same for all the directions, then we will reach the acceleration. The acceleration vector, we studied it before. A as a vector is equal to ax, ay, az in I, j, k hat direction. So fx is equal to the mass multiplied by the acceleration, and the acceleration is equal to x component of the mass divided over the mass of the force, I'm sorry, here. Also, fy is equal to m multiplied by ay, and the same for the z component of the force and the acceleration. Now, our example, if we have a mass 50 kilograms, and we suppose we have these two xy plane, and we have f1 and f2. The direction of f1 is 40 degree, as we see from here, and the direction of f2 is 45 degree. But when we draw them, their starting point from the beginning, from the origin, we need to draw f1 in this case. This is f1, and this is f2. This is f2. Because of this angle is 45, then this one is 45, and this angle is 40. So this is f1 and this is f2. we have x component for each one of them and y component for each one of them. We need to find the acceleration in x direction and the acceleration in y direction. We know the forces, we know the mass. It should be easy to find the acceleration from the two vectors and the mass. So the acceleration vector will be ax I hat plus ay j hat. And the magnitude of that acceleration using the Pythagorean theorem is ax squared ay squared under the root. And the final direction of the acceleration for this object by tan inverse of the y component of the acceleration over the x component of that acceleration. So now we need to find f of x and f of y, because fx we needed to compute the acceleration. We know the mass. We need to find fy. Now fx, this is f1, which has a component on x positive direction, which is f1 cosine 40. And also we have f2 sine 45, because the 45 from the y direction. So x component for the force is f1 cosine 40 plus f2 sine 45, which is 50.68 newtons. Because it is positive, then it is in positive x direction. The y component, we have in two directions. The first one from f1, which is f1 sine 40 on the positive y direction, and we have f1 cosine 45 in negative y direction. So the y component of the force is equal to f1 sine 40 minus f2 cosine 45, which is 48.21 newtons in positive y direction, because it is positive. What is ax? It is fx over the mass, which is 1 in newton almost. 1 meter over square second. Also the acceleration in y direction is equal to fy over the mass, which is 0.96 meter per square second. This is the acceleration vector, which is 1 and 0.96. We can find the magnitude, which is ax squared plus ay squared under the square root, and we can find phi, which is the tan inverse of ay over ax. It will be approximately 45 degrees. This is how we can use Newton's second law. We will use it again and again in the future. It will be more simple with doing the example by your hand. Thank you.